Okay, good evening, cadets. Am I audible?
Yes, sir. Good evening.
Okay, thank you very much. Once again, a very good evening to each one of you. We are meeting exactly after 2 weeks. Last Tuesday, I had to take practicals for NS cadets, so I was not able to conduct the lecture. And next week, we are going to have our class test, CT1. I hope you are aware of that, right? So whatever we'll be doing till today will be the syllabus as far as my section is concerned, and SM Male madam must have told you about her syllabus. Okay, so without wasting much time, let us quickly see. Okay, so last lecture we derived an expression for this. Okay, E is equal to Em sine theta or Em sine omega t or Em sine 2 pi ft. Okay, so let us continue. I'll take you to the TMI LMS. So please allow me. So this is our TMI LMS. Here is the class test one. Okay. And this is what additional thing has been done by my colleague, Male madam. She has put up the soft copy of BL Theraja volume 1 for your reference. Okay. The hard copy of the same will be distributed to you in a due course of time. Right. But in the meanwhile, what you can do is that you can go over there and you can check it out. Okay. So I click on this. Right. And this book pops up. Our AC fundamentals is located on page number 469. Right. So page number 469 is AC fundamentals. Right? So whatever I'll be doing in the class can be found over here. Okay. So let us have a look. This is in the first lecture, I showed you the animated video for this particular one, how a rotating coil in a magnetic field, okay, is able to generate an EMF, or how the EMF gets generated into a rotating coil, which is in a magnetic field. Okay, so this animated movie we saw, right? And the derivation that I was trying to do can be found over here. Right, so you are absolutely free to go through the derivation. Derivation is available over here. E is equal to E is equal to omega n. Okay, the same. E is equal to Em sine theta or Em sine omega t. And for Em, this is what has been written, right? So Em is equal to omega into n into phi m, where omega is the angular velocity, n is the number of turns, phi m is the maximum flux. That can also be written as, maximum flux can also be written as Bm into A, where Bm is the flux density, A is the cross-sectional area, and the omega can be rewritten as 2 into pi into F, right? And there is a solved numerical after this, so you can go through that. Okay, so here is the solved numerical, example number 11.1. Okay, so please go through this particular numerical. Right? It will clarify many of your concepts. Now let me take you to the syllabus. Okay, so this is the syllabus that we are following, that we are guided by. Okay, so here, fundamental of alternating current, specific learning objective has been very clearly given over here. So alternating current, explain how alternating current is produced in a simple loop rotating in magnetic field. We saw the movie for this. Okay, relate the position of the loop in the above objective to the voltage waveform for one cycle. Okay, that also was shown in the movie. Okay, and this was the derivation that I spoke about. Okay, so 1.1.6 is that develop the expression E is equal to BLV to produce E is equal to E max sine theta, where E is the instantaneous voltage, E max is the maximum voltage, and theta is the displaced angle, right? So this is what we have done in the last lecture, right? So if anybody has a doubt, can unmute and ask. Otherwise, please type into the chat box 1.1.6. Okay, meaning that this we have done till here. Okay, wonderful. Let us continue. Okay, then after that, what has been said over here, 1.1.7, okay, 1.1.7, project the vertical component of rotating vector to draw one complete cycle of a sine wave, right? Now, dear guys, this is something really very, very important, because for next calculation in AC, we will be coming across a term called as phasor. Phasor, which is actually abbreviation, stands for phase vector. Okay, phasor stands for phase vector, right? So how an EMF, which is getting induced into the rotating coil, can be represented with a vector? So that will be conceptually explained over here. And for all further calculations, we will forget about the instantaneous value or other things, right? And we will represent the sine wave with a phasor. And this part is that you can apply all the concepts, all the formula of your applied mechanics. You know how when we deal with the vectors, right? We have got triangular rule and other rules. Okay, hypotenuse, you can construct a rhombus and then you can find out the resultant, right? So all those concepts, all those formulas can be used over here, right? So even though we are in electrical domain, the things or the calculation part is in applied mechanics domain, because once it is a vector, it is a vector, right? So therefore, let us start with something called as 1.1.7. Okay, so please allow me to continue. Here we are. Now again, this is the textbook. Okay, now in the textbook, the author has shown it over here. Okay, the author has shown it over here. Now what author has done is that the author has divided the circle, as you can see, number 1, number 2, number 3, number 4, number 5, and number 6. The circle has been divided into 6 equal parts. I said it's not fair, right? So what I have done is that I have divided the circle in 12 equal parts. Okay, and then I have done some geometrical part, right? And whatever I have done is available onto the TMI LMS, right? So first I will show you what I will do is that I will show the constructional part, number one, its electrical significance, and then I will take you to the LMS and I will show you where it has been put up, right? So let us continue. Right, so here we are. Okay, I thoroughly enjoyed doing this part because I like to do a very neat and clean job. Right? So what I did over here was I drew a circle. 1 minute. I drew a circle with radius equal to 3.5 centimeter. Okay. Then what I did was I assumed the value of pi. Okay. By the way, you must be aware that yesterday was the International Pi Day. Are you aware of that?
No, sir.
Yes, because the date happens to be 14th of March, right? So in English calendar, American way, it is represented as 3.14. Okay, which is nothing but the approximate value of pi. So yesterday was the International Pi Day, but nevertheless, for the sake of simplicity, I have taken the value of pi to be equal to 22 by 7, right? So with this pi, with this radius, the circumference will work out to be, if I'm not mistaken, 22 centimeter. Okay, so first understand the geometrical part, and then we will go about the electrical part, right? So the circumference came out to be 22 centimeter. So from here till here is 22 centimeter. Okay. Then as you can see that I have drawn a circle over here. Okay. Now the next task that I have done is that, as you can see, I have divided the circle in 12 equal parts. Now for doing so, right, I use a very rudimentary method. I kept the compass over here. Okay. And then I cut an arc over here. I cut another arc over here. Okay. Then I put the compass. I put the compass over here. Then I cut an arc over here. I put the compass over here, and I cut an arc over here. Okay. And of course, the point which is not seen over here. Okay. That is our 180 degrees. So I managed to divide the circle in 6 equal parts, right? Then I put, this is obviously 90 degrees line. So I put my compass over here, cut an arc over here, cut an arc over here, right? Then I put the compass over here, cut an arc over here, cut an arc over here. And as you can see that I divided the circle in 12 equal parts within no time using minimal geometrical equipments, right? The idea of doing this is that, in exam, the time is going to be essential. Okay. So the less time you use, the more time you'll have for your thinking and writing. Okay. Then after that, as you can see that I projected the lines like this, horizontal lines. Okay. So these were those horizontal lines which represents angle like 30 degrees, 60 degrees, 90 degrees, likewise 120 degrees, likewise. I projected these horizontal lines. That is number 2. Okay. Then number 3, I divided the circumference. Okay. I divided the circumference in 12 equal parts, just as I divided the circle in 12 equal parts, right? So therefore it came out to be somewhere around 1.8 centimeter. Okay. So with that, I marked the degrees over here. Okay, 30 degrees, 60 degrees, likewise. Okay. So therefore the circumference, when I divided in 12 equal parts, I have got every right to denote in terms of degrees, okay, even though it is a length. Okay. So I got these 12 points on my circumference. Okay. Now next part is extremely simple. Okay. Next part, what I did is that I have purposefully retained the construction lines. Okay. I projected the horizontal line. Sorry, I projected the vertical line, and where the horizontal and vertical line, they intersected, I got 1 point, right? So the voltage which will be induced into the rotating coil will have this much of instantaneous value when the coil has rotated by 30 degrees, right? This is second point. So this is the instantaneous value of the coil when it rotated through 60 degrees, then through 90 degrees, okay, then through 120 degrees, then 150 degrees, 180 degrees was 0, then 210, then 240, 270, 300, 330, and 360, right? So I got these 12 points and then I joined them, right? And this is how I did the geometrical part, right? So if this is okay, if the geometrical part is understood, okay, please type into the chat box ND, short form for no doubt. This is as far as the geometrical part was concerned. Now let us see the significance of electrical significance of this. So for that, what I will do is that I will quickly draw a triangle. Okay, I have got a, okay, Hunardeep, no need to draw right now, but please make sure that you practice it at least once, because the question like this can be asked in the examination. Is that okay? 075?
Okay, sir.
Yeah, thank you. In the class, normal class, I would have made you to draw it, but I'm not doing it in the present scenario. Okay. So as I was explaining, the electrical significance of this, right? So this was my vector. Okay. So let us say this vector is R, okay, which is an angle, say theta. Okay. Now I will try and resolve the vector. I try and resolve the vector into, as we have done this in your applied mechanics. Okay. So this becomes something called as the vertical component. Okay, vertical component, and this becomes something called as horizontal component. Okay, so I can represent this vertical component in terms of r and theta as r sine theta. Okay, now let us say if this r was nothing but E max and E was this V was nothing but small e. Okay, so therefore we can see that the vertical component will become E max times sine theta. Right? So E will become equal to E max sine theta, right? So dear cadets, as you can see that very little visualization is required over here. As we try and rotate the vector in anticlockwise direction, okay, as the vector rotates in anticlockwise direction, this is the curve the vector is going to trace, right? And which is nothing but the instantaneous value of the sinusoidal wave at that particular positions, right? So on sampling basis, I have taken some 12 points. You can take more points. The author, as I showed you, Theraja Volume 1 had taken only 6 points. I said इसमें कुछ मजा नहीं है, दम नहीं है. So I said let us do it with 12 points, right? So this is the significance, electrical significance of this vector, right? So as the vector rotates in anticlockwise direction, its projection on y-axis, will give us the instantaneous value. Okay. So if this is understood, please type into the chat box. Understood. Wonderful. Right. Now on my part, what I will do is that I will save this. Right. and I will try and push it onto the chat box. Right. So I have pushed the screenshot into the chat box. Right. Once you receive it, acknowledge it, and then we will continue further. Okay, wonderful. Right, great, great. Okay, just acknowledge I have received already a couple of from Harsh Yadav, right? So just type into the chat box RECD. So I will understand that you have received it. Okay, so here we go, right? So this is, so we have got every right to represent sine wave with a virtual vector. And the tremendous advantage that it will offer is that we can do all the calculations, already the classical calculations which are available with the vector, and things become, basically our life becomes much easier. Okay, so now please allow me to show you where it is. All right, so as I told you, this is where it has been done into the textbook, but as I told you, the author has done it only with the 6 parts, right? So we have gone beyond that, right? So for the sake of further understanding, you can go through this. Okay, and I have also put up, so here is our TMI LMS. Sorry, this is TMI LMS only. So here we go back, right? So phasor representation of sine wave. Okay, now it has been put up like this, right? So you can rotate it, no problem. Okay, so same thing has been put up over here, and the geometrical construction part I have explained you. Okay, so let us continue further. Okay, so here is our syllabus. So what have we achieved so far, right? So we have done this 1.1.6, 1.1.7. State that the rotating vector is called as a phasor, right? Use a triangle produced from the above objective confirms that E upon E max is equal to sine theta. That also we have done. Okay. Superimpose degrees and radians on the sine wave drawn on the above objective, right? So I basically mark the x-axis in terms of degrees, right? And we know the conversion. Right? So everybody knows the conversion, right? 360 degrees is equal to 2 pi radian. Right? So when the circle completes, or when the vector rotates through one cycle, we said that in terms of degrees that it has converted 360 degrees, or in terms of radian it has converted 2 pi radian. Okay, so that also we have done. Okay, now let us move on further. Okay, so here we go. We are back to the Thearaja volume 1. So Thearaja volume 1. Just a minute, I got a call. Normally I do not entertain the call. Give me Yes, extremely sorry. That was the call from one of the parents, right? So I had to request him to call after 1 hour, right? So here we go. Teraja volume 1. I thought so. Sometimes this server or the site plays cranky. Okay. So what I have done is that I have downloaded, of course, that soft copy, and I'll open up that instead of showing it from the TMI LMS. Okay. So here is that soft copy which I already downloaded and available on. I have opened it. So remember page number 469. So here we are, page number 469. Okay, so this part we have done. Okay, now next important thing. Okay, hang on, hang on, hang on. Okay, there are a couple of definitions over here. So 11.6 speaks about something called as cycle. 11.7 speaks about something called as time period, frequency. I'm not going to go through those definitions, right? So please read that, and you will definitely understand that. So my logic is simple. The things that you can understand, right? I'm not going to do that in the class, but I will definitely mention that. Okay, this is what I have done. Okay, and certain things which requires concepts or calculation, definitely that I will do. Okay, now next important thing, we'll be doing couple of derivations. Yeah, 11.11 also you can go through. 11.12 phase difference, please go through. Okay, so we'll be doing these derivations, something called as RMS value and something called as average value. Okay, so here we go. Now I expect that everybody must be seated with uh, a notebook, the notebook that has been provided to you, and with a pen, right? So first, let us go through the definition of the root mean square value. Okay, so the root mean square value of a current is given by that DC current, okay, which when flowing through a given circuit for a given time produces the same heat. Okay, so as shown on the left hand side, here we had a circuit through which the DC current was flowing. Okay, and the resistor was heat up. The current was allowed to flow through a definite amount of time, and it produced some amount of heat. Okay, now through the same resistor, an AC current was made to pass through it for the same time. Okay, uh, alternating current when flowing through the same circuit for the same time must produce the same heat, right? And that value of current is called as root mean square value or the RMS value of the AC current. Okay. Now here we'll try and find out the RMS value of a sinusoidal wave. Okay. So please allow me to share. So here is my whiteboard. Okay. So here I will do the derivation, even though it is given in the textbook. As I told you, I'm not going to read from there. I will rather derive it for your sake. Okay. So let's start. I hope everybody is seated with a pen and the notebooks. Okay. So RMS stands for root mean square. Root mean square value of sine wave. So that derivation we are going to do now. Right. So before I start with the derivation, what I will do is that I will quickly uh, draw your attention to certain concepts, and then we will continue. Right. So here I am trying to sketch one cycle of a sine wave. Okay, so this is one cycle. Right, so here is one cycle. Okay, give me a minute. I'm trying to press some wrong controls. All right. Okay, So this is the negative maximum value. Let's say minus Vm. And this is the maximum value, say plus Vm. Okay, x-axis is going to be theta to reduce the complexity. So this is a half cycle, so therefore pi, and this will be the one complete cycle, so therefore 2 pi. Okay, and the expression for this waveform will be E is equal to, or yeah, as we have used it, E is equal to Em sine theta. Right. So this waveform will be utilizing for the calculation part. That is number one. Number two, I'll just tell you how to find out the average. Okay, average or mean of a quantity. Okay, so as we do in normal classes, right? So let us say you had 4 class tests. First class test you scored 14 marks. Second class test you scored 16 marks. Then third class test you scored 18 marks. Okay, and fourth class test you scored say 20 marks. Right. So in order to find out the average, what we do is that we add them, okay, and then we divide by the number of class tests. Right. So divided by 4. So if I'm not mistaken, the average will come out to be 17. Right. So average works out to be 17. Okay. So same concept will be used. So if I have to find out the average of any wave shape or any function, right? So say I will say average of function. Right. So I will integrate the function over one cycle. Right. So here I integrated the function over one cycle. And I divided by the cycle itself. Okay. So this is how the average of a function is calculated. Okay. So using these concepts, we will continue further. Okay. So here we go. Now we are about to find out something called as the root mean square value of a sinusoidal wave. Okay. So I will say RMS is equal to, so first I will take under root. So we have taken care of the first R. Okay. Now next we have to speak about the mean value, right? So therefore, as we see that the waveform, one cycle is completed over here. Okay. So therefore, the same concept that we used for finding out something called as the mean value. So 1 upon 2 pi. Integral limits are also from 0 to 2 pi. Okay. And the third thing that we have to do is the root of mean of square. Okay. So therefore, I'll square the function. Now the function was Em sine theta. Right. So square of that will become, or I will say Em sine theta whole square. and integrating with respect to theta. So d theta. Okay. Now we have to do the mathematical manipulation and find out, basically simplify this, right? So here we go. Those are good in mathematics. They can run their own race. Otherwise, you can look at the whiteboard, and I hope everybody is writing down whatever I'm doing over here, because I must have done the derivation at least 2 or 3,000 times. Right? So every time this is the sixth division, right? So I have already done 6 times, right? So em square upon 2 pi. Okay, integral limits are 0 to 2 pi. Now we are not happy with the sine square theta. I cannot integrate that, right? So some mathematical manipulation has to be done. Do we remember that? What do we substitute for sine square theta?
Minus cos theta by 2.
Absolutely correct. Absolutely correct. So it is 1 minus cos 2 theta by 2. So I write down 1 minus cos 2 theta by 2, then d theta. And not to forget, the whole thing is under root. So let us continue further. So em square. Okay, those who have got the value by doing the calculation part can give me in the chat box. Okay, we have done this in 10 plus 2, so you know what is the RMS value. Don't do that. Do the calculation. Okay, commit the
1
mistake.
by 2 outside.
Yeah. I hope you have done it in your notebook and you are not recollecting from the 10 plus 2 level. Okay. So therefore, now this 2, I'll take it out common. So I will write down by 4 pi over here. So this will become theta minus sine 2 theta by 2. Okay. Integral limits are from 0 to 2 pi. Okay. And whole thing is again under root. Now I will write next step over here like this. So when we substitute for the values, okay, let us see what will happen to this bracket. Okay. So if I'm not mistaken, this will be 2 pi. Okay. Rest all terms will be 0. So therefore the sign does not matter whether it is plus or whether it is minus, right? So therefore we'll be left with only 2 pi when we put the limits, right? So therefore this function can be rewritten as, or when we solve it, okay, so we can write it down as em square
By 2 pi.
by, yeah, by 2 only, and bracket stays to 1 by 2. Okay, because this pi will cancel with this pi. Okay, this 2 will cancel with this, and I'll be left with em square by 2. And therefore, when we simplify, this will become simply equal to em by root 2. Okay, so if this part is clear,
Yes, sir.
yeah, please type into the chat box RMS so that we can move further and find out the average value of the same wave shape. Okay, so our next objective is to find average value of sine wave. Okay, and you will see that some part of that we have already done. Okay, now a word of caution. While determining the average value of sine wave, always consider half cycle only. Otherwise, what will happen? Any guesses?
Zero हो जाएगा.
It will be zero. Absolutely correct. Okay. Otherwise, it will be zero. Right? I'll make a comment and then we'll start determining something called as average value. Right? Because after this, doing this also, somebody is bound to ask, sir, why are the limits like that? Okay, doesn't matter. So we are ready for that. Right? So here we go. We are about to find out something called as the average value. Okay. So I will say is equal to okay. So as explained over here, when finding out the average value, so I will say 1 upon something. Integral limits are from 0. Okay, now I will just to highlight the point, I'll say that the integral limits are from 0 to pi and also divided by pi. And then Em sine theta d theta. Okay, you are absolutely free to run your own race. No problem. So I'll say 1 upon pi. If I'm not mistaken, the integral, yes, and this will become Em because Em is a constant. So it will come out common. So integral of sine theta will be equal to minus cos theta. And the integral limits are from 0 to pi. Okay. And if I'm not mistaken, this will be something like 1 plus 1. So, sorry, is equal to 2. So therefore, how much will be the average value? Can somebody tell me?
Em by pi.
Wonderful. So it will be twice Em by pi. Great. So if this is also understood, please type into the chat box. Mean value. Yeah. You can say yes, sir, or otherwise mean value. Understood. Absolutely no problem. See what happens that if I ask you to write down understood every time, I am not clear. I mean, whether it is understood
Sir,
that you
whether we want to study that derivation.
1 minute. Yeah, who is that?
Yes, sir.
Yeah, Jitesh, please go ahead. What is your doubt?
Sir, whether we want to study that derivations.
Derivations.
Yes, sir.
Yes, you have to do the derivations because as I told you, your syllabus has been revamped and we have got no precedence. What type of questions are being asked? Okay, so better to do the derivations also.
Okay, sir.
Yeah, okay, thank you. Now what I will do is that I will again save this and I'll put it onto the chat box. and acknowledge that you have received this. Okay. Wonderful. Right. Let us go back to the textbook, what the textbook has to say. So here we are. Okay. So here the author has done the derivation by two different methods. So we have followed this analytical method, and no issue. We can, analytical method is also good enough. Okay. And the value comes out to be I is equal to Im by root 2 or 0.707 times Im. Okay. Same expression that as we got. Okay. Next, RMS value of complex waveform I will not do today, but we will definitely find out the RMS value of some complex waveforms. Average value. Okay. So the same concept, when we have to find out average, right? So we add them up and then we divide by the number of intervals, right? So I1 to In, so you add them and then you divide by n. Okay. So same calculation as we did, and the average value comes out to be something like twice Im by pi. Twice Im by pi. Okay. Then the two next important parameters of the sine wave is something called as the form factor. Okay. So form factor, which is defined as RMS value upon average value. Okay. So after doing calculation, you will see that it is 1.1. And next is crest or peak or amplitude factor, which is defined as maximum value upon RMS value. So after doing the calculation, you will see that it is 1.414. Okay. So these are important characteristics of a sine wave, and we can find out these characteristics for other waves also. Okay. So if you are understood till here, if you are understood till here, please type into the chat box. Okay, 11.19. Okay. And as I told you, your syllabus till class test 1 or class test 1 is going to be till 11.19. Okay. This book has got plenty number of solved numericals. I'll be doing not those solved numericals, but there are unsolved numericals, or plenty number of books which are available. So I have got a decent amount of what you can say database. So we'll be doing those numericals. Okay. So otherwise, you are absolutely free to go through the numericals. So have a look at the solved numericals. Okay, try and solve them. Then what you can do is that you can close your notebook, try and solve the same numerical again without looking into the your notes. I am sure that you'll not be able to do it in first attempt. Okay, you will be able to recollect at least 60 to 70% of the things that you have done. So that becomes your second iteration. And in the third iteration, just have a look at the things that you could not recollect. And in the third iteration, I guarantee you that you'll be able to recollect all the numerical or all the derivations that you have done. Okay. So please don't expect that you read it once and you will be able to do it. Right? It will take about 3 iterations. Right? So to make the things foolproof. Okay. So anybody has a doubt can unmute and ask. Otherwise, this is what I have to do before your CT1. Okay. Otherwise, please type into the chat box, no doubt, so that I can end the lecture. Okay, great. Who is the CR of our division?
I'm DCR duty.
Okay, okay. Sorry, I could not get. Yes, yes. DCR
Yes, sir.
80 Sahil. Okay.
Yes, sir.
Yeah. So Sahil, one fellow from our division has been migrated to I think division 4 or 5. You are aware of that?
Yes, sir. Manthan Atte.
Okay. What is his number? Manthan's number?
I think so. Wait, sir. I think so 073, but I will check and tell you.
Yes, Hatte. Manthan Hatte. Okay.
Yes, sir.
Yes. So he has been shifted to division.
Division 4, I think so.
Okay, okay. Right. So that leaves our division 34 minus 1, 33, right? So
Yes, sir. 33
yeah,
students.
Sahil, so how many absentees today?
4 absentees.
Okay, can you tell me the number?
Yes, sir. 2 minutes, sir.
Excuse me, sir.
Yes, go ahead, Dhruv. What do you want?
Sir, Prathamesh is with me.
Okay, okay. Prathamesh, who? What's his number?
Good evening, sir.
Yeah, good evening.
Sir, I am Animesh Garge, CR.
Okay, you're speaking with Sahil only.
But sir, I was in the meeting, but as I had now I had came for haircut, so I got logged out from the lecture. So I am with Sahil.
Okay, okay. What you said here, I could not get your name, CR.
Animesh Garge 064, sir. So I will send you the absentee on your WhatsApp number.
064. Okay.
Yes, sir, I have taken the screenshot, so I will send the absentee number on your WhatsApp.
Okay, okay. Yeah, 1 minute. As you are aware that, just give me a minute. Let me see if I can revoke this thing.
Which thing, sir?
No, I am trying to, can you see the screen? I am trying to connect to TMI LMS, right?
Yes,
So-
yes, sir. Yes, sir.
Okay. No, right now I am not able to do, right? So that TMI LMS also has got the attendance thing, right? So the division list has been updated and the attendance thing has been put up over there. No, server looks to be inaccessible, right? So I keep on updating the attendance over there, right? So no problem. Animesh, you can send me the absent numbers and I will immediately update that. Is that okay?
Yes, yes,
Yeah,
sure,
yeah,
sir.
yeah.
Animesh Prathamesh is with me.
Yeah.
Okay,
Yeah.
Harsh, no problem.
1 minute. Just give me a minute. What I will do is that I'll immediately mark the attendance.
Okay, sir.
Okay.
Sir, but the thing is that the 3 students are not there, and the Prathamesh is with Harsh. Similarly, I am with Sahil. So, and one person I am finding him. Who is he?
Okay, so I will give you benefit of doubt. Absolutely no issue. I am trusting you, right? So whatever inputs you give me, I will go according to that because it is not
Yes,
possible.
sir. As I got the inputs, I am forwarding with you, sir.
Okay.
So, as students are saying he is with him, so we can understand them now because tomorrow we are having haircut inspection, so we can't do anything.
Okay. Yeah. So Animesh, please send me the authenticated list and I will mark the attendance accordingly, right? So are you going to send it now or shall I end the lecture?
So you can end the lecture. According to me, all are present because as Harsh said, Prathamesh is with him. I am with Sahil. So 30 plus 2, 32. And I had taken the screenshot. I will inform you afterwards.
Okay. Absolutely no problem. Right. So dear cadets, thank you very much. I don't think I will have a lecture before your CT1. So wishing you all the best.
Thank you, sir.
Yeah. Okay. Jai Hind, cadets. Jai Hind.